Hello and welcome back to another episode of Math with Sohn. Today is part 2, given key features of graphs, sketch the graph and determine what's going on afterwards. So if you haven't seen part 1, highly recommend it. It goes over what are these key features. This is the upgraded version, which sometimes people think is easier because you just have to sketch the graph. All right? So we're going to start with the easiest part. Always start with the easiest part because sometimes that's enough to do the entire problem. We're going to graph our x-intercepts at 3, 0 and negative 3, 0. So 3, 0, 1, 2, 3, and negative 3, 1, 2, 3. So those are my x-intercepts. The graph will have to curve through that in some way. It also has a y-intercept at 4. 1, 2, 3, 4. So those are done. Nice. The last bit is it's just having the end behavior. That's what this part is here. X approaches infinity as f of x is approaching negative infinity. So on the right side, we need to go down. And on the left side, x approaches negative infinity, we also need to go down. This is representing down and down for both of the f of x part. And this is representing the right side and the left side. So on the left side and the right side, we need to go down. Notice that I just did it on kind of the end of the graph. All right, so that's what I did there. Now I'm probably just going to connect the dots. So let's see if we got going on here. We got to connect the dots. We got to connect the dots. That is probably going to be the graph. It might be a little bit different because the graph could have kind of curved and done some crazy stuff in the middle. Like, for example, it could have done, I don't know, something like this. But most likely it is the graph that we did in red. All right? So, sketch the graph, done. Determine the intervals of increasing and decreasing. I'm going to do it on the red graph. It is decreasing from this y-intercept, and it is increasing up into the y-intercept. So here we're increasing. Here we are decreasing. Okay, so it is increasing from negative infinity up until not 4, but 0. You put the x value here. When you're doing increasing and decreasing, it is only focusing on the x values, and the x values right there is 0. So it is increasing from negative infinity to 0. It is decreasing from 0 to positive infinity, because over here we have positive infinity. Yeah, it's going down, but we're again focusing on the x values, which is going from left to right. Determine if the function is even or odd. Well, it's not odd. It could and is most likely even. There's a chance that it's not. Again, there's a chance that it could be this one, but it is most likely even. It could be an even. It definitely can't be an odd function at this point. Okay, let's do another one. Given these key features, is it possible for it to have an x-intercept at negative 1, 0? Well, let's start by maybe graphing a little bit of it. It is decreasing from negative 3 to 0. It is increasing from negative infinity to negative 3 and from 0 to positive infinity. So let's say that it's increasing from negative infinity to negative 3. So that means that it's going up until you get to the point of negative 3. 1, 2, 3. Okay? It is also increasing from 0 to infinity. So from 0 to infinity, it is also increasing. So from 0 to infinity, it is also going up. So where could that be? Well, we know we're going down from negative 3 to 0, so that could be here. And then it could be increasing again from here to infinity. Okay, so see how here we're going up until we get to negative 3. And then we're going down from negative 3 to 0. And then we're going back up again forever. Okay, so that's one version of the graph. And in this version of the graph, is it possible to have an x-intercept at negative 1? Yes, it is possible to have an x-intercept at negative 1. It also has some other x-intercepts if that's the case. It has this one and this one. We don't know what they are. But we do know that it has 1, 2, 3 x-intercepts in the way that we currently graphed it. Did we have to graph it that way? No. We could have done this entire graph from negative infinity to negative 3, and then going down, and then going back up. And in this case, the way that I graphed here, it doesn't have an x-intercept at negative 1, 0. So it didn't have to, but it is possible to have that x-intercept. So there are multiple ways that it could have been graphed, which is why part B, it says sketch the graph with an x-intercept at negative 1, 0, if possible. So it is possible, but it is not required by all means. Last bit is determine the end behavior. In both graphs, the end behavior remains the same. See how it's ending like left side going down, right side going up, left side going down, right side going up. So x approaches infinity, x approaches negative infinity as f of x approaches blank, as f of x approaches blank. That's the setup every time. So on the right side, this is the right side, are we going up or down? On the right side, we are going up. So this is positive infinity. On the left side, we are going down. This is down. So that's negative infinity. Okay? Next one and last one. Maybe this video will be 8 minutes. That'd be nice. Given these key features, positive from negative infinity to negative 5, and from 2 to infinity, negative from 5 to 2, and increasing from negative infinity to 0 and from 1 to infinity. We need to sketch the graph. So let's start with the positive. Let's start with the negatives. The negatives, well, the positives. Okay? This is one where I would recommend if you were doing it on your own, you do it maybe on a scrap sheet of paper first or with a pencil first because there's a chance you could make a mistake. So positive from negative infinity to negative 5. So up until we get to the point of negative 5, 1, 2, 3, 4, 5, we are positive. So it is doing something like that. And then it goes negative from 5 to 2. So I know that from 5 to 2, it's going to be doing something down here, and it is going to be, at that point, it is going to have to be positive again, which is what happens here. From 2 to infinity, it is positive. So we've done the positive part on both features. I omitted the negative because I know a little bit about this problem. I made it. All right? So from 5 to 2, it is negative, but there's some craziness happening here when we're doing it. It is increasing from 1 to infinity, and it is increasing from negative 3 to 0. So at negative 3, 1, 2, 3, negative 3, that's when we start going back up. So at negative 3, it is going to have a minimum value, and we're going to start going back up all the way up until we get to the point of 0. And then at 0, we can't be going up anymore, so we must be going down. And then it starts increasing again at 1, like I have here. Okay? So this is the part where if you didn't have a little bit of an inclination, you might have to mess up and then erase a little bit and retry. Okay? So let's make sure that I did everything right. We have it going positive from negative infinity to negative 5. Negative infinity to negative 5, we are above the water, so good there. Positive from 2 to infinity, above the water at 2, good there. Negative from 5, negative 5 to positive 2. That's a typo, we got to fix that. From negative 5 to positive 2, right here. That is where it is negative. What about increasing? It is increasing from negative 3 to 0, yes, and from 1 to the end of time. Yes. Okay, so graph is complete. Determine the end behavior for this graph. On the left side and the right side, f of x is going up. Okay, so f of x is positive and f of x is positive. Remember, it's the same setup. There's always a left and right. You just have to fill in the up and down. List any unknowns for this graph. Okay, well, one thing that's unknown is we don't know what these mins and maxes are. Okay, so we don't know what the mins or maxes are. And we also don't really know where this y-intercept should be. We know that it is increasing from negative 3 up until 0 for x, but we don't know where that x value is. Is it where I have it? Is it further down? We don't know. We also don't know the y-intercept. We do know the x-intercepts of the graph. Even though we weren't expected to find it, if you know when it is positive and negative, you know the x-intercepts of the graph every single time with that. All right, that's going to do it for this one. Until next time, my friends, stay positive, and I will see y'all later. Bye.